In this video we're going to look at factorising quadratic trinomials. So when we factorise quadratic trinomials, we call it factorisation by inspection. And just as a note, a quadratic trinomial has three terms: an x squared term, an x term and a constant term. As a general form we can express that as a number a times x squared plus a number b times x plus a number c. On the left hand side I've got a CAS calculator's screen to have expanded and factorised form of several different quadratic trinomials. So as you can see, if we expand x plus 2 times x plus 5, we get x squared plus 7x plus 10. And if we factor x squared plus 7x plus 10, we get the same factorised form that we expanded in the line above, which is x plus 5 times x plus 2. So you might see that the 5 and the 2 multiply to give 10 and they add together to give 7. And that's a pattern that we can see all the way down the calculator screen. We can see that negative 6 and 3 multiply to give negative 18 and add to give negative 3. And those terms are the C term is what they multiply to be, and the B term is what they add to be. If we look down a little bit further, we can see x take 4 times x take 5. The negative 4 and the negative 5 multiply to give positive 20 and add together to give negative 9. So we can use this pattern to help develop some sort of rule or some sort of process to factorise by inspection. And just to have a look at a more general case, we're going to consider the following expansion. In the first bracket we're going to have x plus some number m, and in the second bracket we're going to have x plus some number n. And now we're going to set up a grid to expand that. So down here we could have x plus m, and across the top we can have x plus n, and multiplying x times x gives x squared in this position, then positive n times x, that's just plus nx, x times positive m is just plus m times x, and n times m is just plus mn. So that means that when we expand this out, we get x squared plus mx plus nx plus mn. And we can do one more thing to this to unlock the pattern that we're going to use when we factorise by inspection, and that's going to be to factorise the x out of these two terms. So that means that this can be written as x squared plus, and then if we have mx plus nx, x is a common factor, and we can write in here m plus n, and then we still have the plus m times n at the end. And that's why if we start in this unfactorised or fully expanded form, we can look for two numbers m and n that multiply to give the plus c term, which is the constant term in the quadratic trinomial here, and add together m plus n to give the coefficient of the x term or the b term in the quadratic trinomial. So we're going to use this pattern in the next few examples to factorise quadratic trinomials by inspection. So for the next few examples we're going to factorise each of the following expressions, and we're going to do it using by inspection. So if you remember back to the previous slide, we're looking for factors of 15, and that's the constant term here, that add to give 8, and that's the plus b term here. So if we start with the factors of 15, we can have 1 and 15, or we could have 3 and 5, and then we run out of other factors. And we can see if we have 1 plus 15, that equals 16, so that's not 8, so we don't want that one. But if we have 3 plus 5, then that does equal 8. So that is the pair of numbers that we can use to factorise by inspection. So now that we have those two numbers, we simply factorise this as x plus 3 times x plus 5. And that is the factorised form. So we won't do this for all of the examples, but we can check this, that we have got it right, and we can do that by expanding. So if we put x plus 3 in blue, and we have the x plus 5 in green, we can set up a grid to help us expand this. And down here we'll have x plus 3, and across the top we'll have x plus 5, and this will give us x squared plus 5x plus 3x plus 15. And within that we can identify two like terms, plus 3x and plus 5x, which means that when we have this fully expanded we get x squared plus 8x, and that's the 5x and the 3x combining, plus 15. And as you can see, all three of those terms are the three terms we started with up here. So that means that the process of looking for the factors of 15 that add up to 8 did manage to give us the correct factorized form. So at this point in time I would encourage you to pause the video and have a go at question B for yourself before I do it for you. So now if we do question B, our task is to find the factors of negative 12 that add up to negative 4. So negative 12 actually has quite a number of factors because we'll need positives and negatives to multiply together to give a negative number. So we can start off with 1 and negative 12, or negative 1 and positive 12, or 2 and negative 6, or negative 2 and positive 6, or 3 and negative 4, or 4 and negative 3. And now the second part of the task is to find the pair that add to negative 4. So you could go through and do all of these. We'll just quickly go from the top down and see which one comes up with negative 4. So 1 and negative 12 is negative 11 when added together. Then the next two give positive 11, and then 2, and then adding on negative 6 does in fact give negative 4. So it means these are the two numbers that we can use to factorize by inspection. So as we have our numbers, we can simply write this as x, and it's going to be plus 2 times x subtract 6, and that would be the factorized form for part B. And now we're not going to check that by expanding like we did in part A, but that's certainly something that you could do. And when we're factorizing monic trinomials, so monic trinomials is probably a new word for you, and that's simply when we have a trinomial where the x squared term has a coefficient of 1, or there's really no number that appears to be multiplying that term. So we can see for parts A and B there's a 1x squared in both of those, with making it a monic trinomial. We refer to the factorization by inspection as being by inspection easy, and that's just so I can refer to it by an easy title. For part C we have the quadratic trinomial 2x squared minus 6x minus 20. And you might think that this is a non-monic trinomial, and you'd be quite correct because the coefficient of x squared isn't 1, it's 2. However, we can simplify it by removing a highest common factor first. So if we do remove a highest common factor of 2, and 2 is a common factor of all three of those terms, inside the brackets we'll have x squared minus 3x minus 10. And inside those brackets is now a monic trinomial that we can factorize by inspection easy. So now to factorize by inspection easy, we're going to look for the factors of negative 10 that add to give negative 3. So once again there's a number of combinations, positive and negative numbers, that multiply to give negative 10. So we can have 1 and negative 10, or you could have negative 1 and 10, or you could have 2 and negative 5, or negative 2 and positive 5. So the next part of the process is to identify the pair of factors that add to negative 3. And if you look down the list you can see 2 subtract 5, so if we add those two terms together, 2 subtract 5 is equal to negative 3. So we can use these two numbers to help us factorize by inspection this trinomial. So now that we have those two numbers, the factorized form just becomes 2 times, and it's going to be x plus 2 times x minus 5. And you could check that's the correct answer to part C by expanding. Once again, you might like to have a go at part D before I do it for you. So as with part C, we're going to remove a highest common factor first. So that means this will equal, and negative 4 is our highest common factor, leaving behind x squared. And if we take negative 4 out, we actually have plus 6x as the next term. And taking negative 4 out of negative 36 will leave plus 9 in this last position. And the bit inside the brackets is now a monic trinomial, which we can factorize by inspection easy. So our task here will be finding the factors of 9 that add up to 6. So for this example, I'd like to illustrate that getting positive 9 can actually involve two negative numbers, but we'll see in a moment why we don't want them for this particular question. So the factors of 9 are actually 1 and 9, and you could also have negative 1 times negative 9, or you can have 3 and 3, or you could even have -3 and -3. Now, because we want our two numbers to add up to a positive number, that is +6, we only actually needed to consider the positive case. So 1 plus 9 is 10, so that's no good, but 3 plus 3 is equal to 6. So these are the two numbers we can use to factorize that trinomial. So in our next line of working, we'd still have -4 multiplying this. We'd have x plus 3 and x plus 3 in brackets. And now in maths, we know that if we multiply two numbers together, we can write that as the number squared. So the same thing applies with algebra. This can be written as -4 x plus 3 all squared. And that also means that that quadratic trinomial x squared plus 6x plus 9 is what we call a perfect square, because it can be written as something, x plus 3 all squared. Once again, you could check that that's the right factorized form by expanding that out using a grid. And just as a note, for some quadratics we can remove a highest common factor first and then still factorize by inspection, and once we get rid of that highest common factor it becomes by inspection, and it's called easy, that process, or that's what I'm going to refer to it as in this video. For our next two examples, E and F, you can see that they are non-monic quadratic trinomials because the coefficient of x squared, that number multiplying it, is not 1. The first trinomial has 3 multiplying x squared, and the next one has -2 multiplying x squared. And unlike our previous examples, 3 is not a common factor of all three terms, and the -2 is not a factor of all three terms in that second quadratic we have on this page. Which means we can't factorize this by inspection easy. Instead, we have another inspection technique, which we're going to call by inspection hard. So for non-monic trinomials, where the coefficient is not 1, we factorize by inspection, and we're going to refer to that process as by inspection hard, because it's got just that extra step that you'll see in a moment involved. And the extra step is, we don't just look for the factors of 10 that add up to 17, we actually multiply the a and the c term, or the coefficient of x squared, by the constant. So we're going to have 3 times 10, and we look for the factors of now 30 that add up to 17. So listing out the factors of 30, we're going to have 1 and 30, we could have 2 and 15, we could have 3 and 10, or we could have 5 and 6. And now our job here is to find the pair that add up to 17, and we can see that 2 plus 15 equals 17. So these are the two numbers that we can use to help factorize this quadratic trinomial. However, for by inspection hard, we can't go straight to the factorized form. We actually use these two numbers to split the middle term. So we can write this as 3x squared, and then we go plus 15x plus 2x. So 15x plus 2x is still 17x, we've just split it up, and we'd still have plus 10. And this now gives us 4 terms which we know we can factorize by grouping 2 and 2. So I'm going to group these first two terms together, and you might now see why I put 15x next to the 3x squared, because they have a common factor of 3x. And we're also going to group the last two terms together. So the next line in this working will be that there's a highest common factor of 3x for the first two terms, leaving behind x plus 5. And in the green, the highest common factor is 2, leaving behind x plus 5. And now we can see that x plus 5 is a highest common factor of those two terms. So when we finish factorizing this, we remove x plus 5 as a highest common factor, which leaves behind the 3x that was multiplying the x plus 5 in blue, and the positive 2 which was multiplying the x plus 5 in green. So that is the factorized form for example E. And as you can see, that process was a little bit harder than when we did this by inspection easy for monic trinomials, and that's why we've simply called it by inspection hard. Now it's going to be worthwhile for you pausing the video and having a go at F before I do it for you. So if we do F, it has that same process where we're going to need to multiply -2 by the 20, so that we're looking for the factors of -40. And we need those to add to -3. So listing those factors out, for -40 we have 1 and -40, or we could have -1 and +40, or we could have 2 and -20, or we could have -2 and +20. And now 3 doesn't work, but 4 does, so I'll just continue over here. So we could have the combination of 4 and -10, or -4 and 10. And we could also have 5 and -8, or -5 and 8. And as always, we now need to look through this list and see which 2 add to -3. And you can see 5, and if we add on -8, that does equal -3. So we're going to use those two numbers to help factorize this quadratic trinomial. So as with the first example, this is going to now equal -2x squared, and we use the 5 and the -8 to split up the middle terms. And I'm going to put -8x here, and then plus 5x plus 20. And again, the reason why I chose that order for the middle terms, and it really doesn't matter, but I could see that -2x squared and -8x had a lot in common, as did 5x and 20. So now when we group it 2 and 2, I'm going to group these two things together, and I'm going to group the last two terms together. So we can now pull out a highest common factor from each of those. So in the blue, we're going to remove -2x, leaving behind x plus 4, and just be careful of your negatives there. And in the green, we're going to pull out a common factor of 5, leaving behind again x plus 4. And you'll know if everything's going well because in those brackets should be the same term. And because it's the same term, we can now pull it out as a common factor. So our final answer is going to be x plus 4, which is the common factor between the two terms now, multiplied by, and we had -2x multiplying x plus 4 in the blue, and we had plus 5 multiplying the x plus 4 in green. So that means that that is the factorized form for part F. And again, as with all of these examples, you could check that by expanding. So after this video, you should be able to understand that factorizing is essentially the opposite of expanding brackets. You should be able to factorize a monic quadratic trinomial by inspection easy. You should be able to remove a common factor first and then factorize by inspection easy. And where you can't remove a highest common factor, meaning that it's a true non-monic quadratic trinomial, we can factorize that by inspection hard, which involves a couple of extra steps which we saw in the last two examples.